Okay, so as I mentioned earlier, starch is advantageous because it is non-toxic on one hand, and then if you can prepare thinner slabs of the gel, then heat dissipation is more easy, and therefore there will be no distortions in the separation of sample components. Okay, but a drawback of starch is that it is not of a uniform quality, and therefore there will be lab to lab variations. There could be between the experiment variations. Okay, and advantages, again, you can say that it is biodegradable. Okay, so even after your work is over, when you dispose of this material, then it can be easily biodegraded, and therefore from an environmental point of view, it doesn't pose any threat. Okay, it is also useful for large scale screening. What is large scale screening? Large scale screening means you can screen, you can test a large number of samples. Okay, so there is no limit on how many samples you can test using starch gel electrophoresis. Okay, so going to the next point. Now here we have these two types of variations in electrophoresis. One is called as the vertical electrophoresis unit, and the other is called horizontal electrophoresis unit. Okay, so I have already explained you this design of the electrophoresis apparatus. We have the upper and the lower tanks, which are filled with buffers. The buffers are usually the same. Okay, so whatever buffer is put in the upper tank, the same buffer is also put in the lower tank. What should be the characteristics of the buffer? What are the important properties of the buffer? There are two things by which you identify a buffer. Yes.
First, it having the ability to separate the charges.
Separate the charges? How?
Flow of electricity from it.
Yes, yes, yes.
While
So the essential thing about the buffer is that it should have the ions, okay, which will be able to carry electric current. Okay, so basically the buffer has a particular strength, isn't it? Strength, that is the concentration. So whatever ions are present in the buffer, there has to be a certain concentration of these ions, so that during your electrophoresis run, say it may be 3 hours run, or it may be like the older times it was 15 to 16 hours. So during that period of time, the ion should continuously flow from the negative electrode to the positive electrode. So that much quantity of ions should be present in the buffer, which will allow the electric flow to take place continuously. Okay, another important property of the buffer is the pH. Okay, why pH is important? Because pH will determine the molecular charge of the sample components, isn't it? As we have, I have been repeating this statement, and I am going to again repeat this statement again and again, that if the buffer pH is higher than the isoelectric point of the molecules under question, then what will happen? Your sample molecules will carry a net negative charge. And if the buffer pH is lower than the isoelectric point, then your sample molecules will carry a positive charge, isn't it? So definitely the property of the buffer, that is the pH of the buffer, will determine the charge on your sample molecules. Okay, and your electrophoretic separation is going to take place on the basis of the charges, isn't it? So what should be the pH of the buffer? That will depend again upon your sample molecules, right? So if you have some idea about your sample molecules, then you can likewise adjust the pH of your buffer system, right? In other words, you can determine, you can decide whether your proteins in the sample should carry a more negative charge, or a less negative charge, or a more positive charge, or a less positive charge, right? Then if we compare between these two materials, acrylamide gel and agarose gel, okay, agarose as well as starch gel, then acrylamide is a little more rigid type of a gel. What is the meaning of rigid?
It having the molecules very close.
Okay, what is the
Means
meaning
there
of
is
rigid?
no molecular space.
No, that is one thing. Yeah, that
is
is one thing. But what is rigid and fragile? Rigid and the opposite is fragile.
Fragile can be easily broken down.
Yes. हा, काय करता येणार नाही?
ते जास्त बेंड होणार नाही असं.
Right. Okay. So fragile is something which is, you can say, a brittle gel or something which is so soft that it will easily get torn apart or it will get cracked up during the electrophoresis. So agarose and starch is something like that. Okay. Very soft. As compared to that, acrylamide gels are more, you can say, rigid. That is, they cannot break up very easily. Okay. And therefore now if you want to make a choice of whether you want to do vertical electrophoresis or horizontal electrophoresis. Okay. And if you use agarose or starch in the vertical electrophoresis, then what will happen? If you are putting it straight like this, okay, gel is kept like this, vertical, then what will happen? Because of the fragility of agarose or starch, the gel will just crumble down. Okay, it will fall down. It won't stand upright. On the other hand, acrylamide being more rigid, it will stand in the vertical gel apparatus properly. It won't fall down or it will not break up. Is it okay?
Yes, sir.
Okay.
Yes, sir.
So you should understand that if you want to do vertical electrophoresis, then which gel you should use, and if you want to do agarose horizontal gel, then which gel you can use, right? Okay, then coming to this part, the gel is formed. Gel is formed. That is, we allow the gel to be prepared within two glass plates. Okay, so if this is glass plate one, this is another glass plate, and between these two glass plates, there is a small gap. How we maintain the gap? How is the gap maintained? It is by the use of something which is called as a spacer. Have you heard this word, spacer? Okay, plastic spacer. I'll just show you some example. I'll try to show you something. Okay, I have this. So this is a paper actually, but this is one glass plate. This is another glass plate. Can you see me? Okay.
Yes, sir.
And between these two glass plates, what I'm going to do is I'll put something like this in between here. Can you see what I have done?
Yes, sir.
Yes, sir.
So in between the two glass plates, I have placed a piece of plastic material, okay, from all the sides, maybe from the three sides, side one, the lower side, and this side. So if I keep these plastic spacers along the three sides, then what will happen? I'll be able to make something like a chamber. Okay, the two glass plates, and on the three sides there are plastic spacers. Okay, so I get something like a chamber. Do you get me what I'm saying?
Yes, sir.
Okay,
Yes,
but the thickness
sir.
of the chamber is not very great. It is a very thin. There is a small distance between the two glass plates, isn't it? And then between these two glass plates, what I do, I put the jelly material, which is liquid. Okay, agarose, for
Yes.
example, if you know, when we boil the we put agarose in buffer. Okay, same buffer that we are going to put in the upper and the lower tank. Okay, and then we boil this agarose. We mix it properly and we boil it. So what will happen when we boil? The agarose will get melted. It will melt. Okay, it will become a liquid solution, and then this solution, while it is still hot, we pour it in the on a you can say, of course agarose we are using for horizontal. Okay, I'm talking about acrylamide. So in acrylamide, what we do is we have two chemicals. One is called as acrylamide, and the other is called bisacrylamide. Okay, so when we mix the two together and we put some chemical reagents like a catalyst and an initiator. Okay, TEMED. I'll come to that slide once again after some time. Okay, but when we put these chemicals, and what will happen? The acrylamide and bisacrylamide, they will form cross links. Okay, and then we get the gel material. This gel material is already poured in the two glass plates. Now, when we allow it to stand at room temperature for some time, then what will happen? A solid gel will be formed between the plates. But before the solid gel is formed, what we do, we have a particular thing which is called as a comb. Can you see this slide here? Looks
Yes,
like
sir.
आपण कंगवा वापरतो ना केस विंचरायला. तशा प्रकारचा एक मटेरियल आहे, एक डिव्हाइस आहे. दिस इज कॉल्ड एज अ कोम्ब. Okay, and you can see that the teeth of this comb are having the some dimensions, म्हणजे एक uniform size आहे त्यांची. Okay, teeth of the comb. Now what we do is we put this comb between the two glass plates from the top side. From the top side, कारण other three sides are already occupied by the spacer, isn't it? The top side is still empty. So from the top side, you put the comb inside while the gel is still liquid. Okay. And when the gel solidifies, then what will happen? You just remove the comb from the top. Then what will happen? You will get the wells in the gel, right? So that is how we make gels in polyacrylamide gel, in the vertical gel electrophoresis, right? You can make, say, up to 20 wells in by using one comb in the gel. After that, what you do? After the comb, after the wells are made, then we put, actually this particular gel casting is done in a separate unit. Okay, we are not making the gel or the wells in this apparatus itself. Okay, there is a separate apparatus in which we make the gel, and after the gel is solidified, then we remove the glass plates from that apparatus and we put it in the main electrophoresis unit here, like this. Okay, another thing which I should tell you is that while you are putting the glass plates in the electrophoresis apparatus, you have to remove the spacer arm from the lower end of the plates. That is, can you see in this diagram, this lower side? Okay, we had put spacer arms here, here, and here. Do you remember that? From the three sides. And on the top, we had put the comb. Okay, so comb you remove first. And then these glass plates, before you are keeping it in the electrophoresis apparatus, you remove this lower spacer, plastic spacer. Okay, and then you put the plate. So now what will happen when you put the plate? The gel will be in contact with the buffer from the lower side. Is it okay?
Yes, sir.
Okay. And then when you put the buffer in the upper tank, okay, and when you have removed the comb, then naturally what will happen? The buffer, the top tank buffer, okay, also will be in contact with the gel. Okay, so all the wells are actually getting filled up with the buffer solution from the top. In other words, the top of the gel and the bottom of the gel are now both in contact with the buffer solutions, right? Yes. Then the next part is to load the sample. Okay, now here they have shown 1, 2, and 3 types of combs. Okay, comb number 1, what is the specialty? Okay, you
It
will
having
get,
a specific size.
it is having, there
Uh,
is a particular size of the well. Okay, there is
yes.
a particular, you can say, height of the well, and there is a width of the well. Okay, that is because of these teeth. Okay, and in between two wells, now suppose this tooth was making one well and this tooth was making another well, so between the two wells there is a distance here. Okay, the distance between the wells is almost equal to the width of the well. Can you see that? So between every two wells there is a gap. Okay, so two wells are not very close to each other. But you see the other comb here, another comb. When you put this comb, what will happen? The distance between the two wells is very, very less, actually. Okay, distance between the wells is very less. And the problem with such combs is that there is a possibility that sample from one well might get spilled over into the another well. Okay, so advantage of this second comb is what? You can have more number of wells in the same gel. Okay, suppose here you are having 20 wells, then here you can have 30 wells because the wells are all close to each other, isn't it?
Yes.
So because the gap is minimized, you can have more wells in the second type. But the drawback here is that there is a chance of sample spilling over into the other wells.
Another well.
Yes. Okay. Now, can you say something about the third comb? Look at the diagram here, and then you tell me what is the specialty of the third comb.
Sir, in the large one, we can put the sample, a large amount of sample, and in the smaller well, we can put
Yes, certain
ladder.
small amount
Separate
of
ladder.
sample.
Yeah.
Yes,
So,
sir. For standardizing, we can put on ladder
yes.
to compare them.
So, but in other words, now there are two teeth only in this particular comb. There is a tooth number 1 and there is a tooth number 2, isn't it?
Two.
Tooth number 1 is very small one, so you can put small amount of sample, and in the other tooth, we are going to get a very large well. Okay, large well, that is how much? It is actually a combination of all these wells together, isn't it? So we get a huge well here because of this comb. The idea here is that we can put a large amount of sample. Sometimes for what kind of work we require that? This is called as a preparative comb.
So for extraction purpose, to extract out.
Yes, yes, very good. Okay, so instead of using the word extraction purpose, we are going to use the word preparative application. Okay, what is preparative application? After your separation is over, after your electrophoresis is over, you can take out the desired band from that gel. Okay, whatever sample component is purified, that purified band you can take out from the gel, and then you can use it for some application on a large scale. Is it okay? So
Yes,
whenever
sir.
you require your sample, purified sample component on a large scale, you can use this kind of a comb, which is called as a preparative comb. Right? Okay. So then we go to another type of electrophoresis unit that is called as a horizontal electrophoresis unit. Now, can you see the diagram here? There's a this is the electrophoresis apparatus. Okay. It contains only a single chamber. Okay, it is not like the vertical one. There were two chambers in the vertical gel electrophoresis, but here we have only one chamber. Okay, now within this chamber we put the buffer, and in the buffer we have this slab gel. Can you see this slab? Okay, so here also we have two different units. One unit is called as the casting unit. So on the making use of the casting unit, we can actually make the gel. Okay, there is a small tray. Inside the tray we put cellophane paper or sticking tape on all the sides. Okay, and then we pour the agarose, which is molten or heated agarose. Okay, and then when we allow it to before cooling it, we put the comb. Here the comb is of a different type, so you can put the comb here. Okay, from the top. Okay, that is one side of the gel. Either you can put the comb at the center of the gel, or you can put the comb at any one side of the gel. Okay, now there is a difference here. In case of the vertical gel electrophoresis, we could make the wells only at the top of the gel. Do you remember? There was no
Yes, sir.
chance of making the wells at the center. Okay, so wells were made at the top. But in the horizontal gel electrophoresis apparatus, you can either make the wells at the center, or you can make the wells at the one end, either this end or this end. But which end we are going to prefer? We are going to prefer the end which is going to be closer to the negative electrode. Why? Because electric current will flow from the negative electrode to the positive electrode, isn't it?
Positive.
So after having poured the agarose in the casting unit, we wait for some time until the gel is cooled. So below 40 degrees centigrade, what will happen? The agarose will start polymerizing and it will become a solid agarose platform, okay, or solid slab. Now this slab is removed from the casting unit. Okay, the cellophane tapes are removed. And then what we do? We put the agarose slab in the electrophoresis unit. Now, of course, this electrophoresis unit actually, although it looks like one chamber, it is actually a double chamber. Okay, because can you see this elevation here? Okay, there is a reservoir here, buffer reservoir here. There is an elevation. On this elevation, we are putting the agarose slab. Okay, and there is another reservoir here. So we put the buffer here, okay, on one side. We are also putting the buffer here, but we are also allowing the buffer to flow on this platform. Okay, what we are doing, we are allowing the buffer to flow over the platform so that this complete gel is also in contact with the buffer, right? Now many times what we do, we allow the buffer to actually go over the gel. Okay, so our gel is actually submerged in the buffer, and therefore this kind of electrophoresis is also called as submerged gel electrophoresis. Okay, do you understand what I'm saying?
Yes, sir.
Okay, this is called submerged gel electrophoresis because many a times the gel is actually inside the buffer. The buffer is covering the gel. Okay, and then the buffer is also present in the two reservoirs, and these reservoirs are connected to the electrodes. Can you see here negative terminal and positive terminal, right? Some people sometimes, okay, in some situations, the people do not allow the buffer to actually go over the gel. Okay, buffer is little lesser. Okay, for whatever advantage they may probably have. Probably sometimes the quantity of buffer is less, and therefore they do not have enough quantity to actually overlay the gel. But other than that, what could be the advantage? When we put the sample in the wells, okay, we are going to put the samples inside the wells. So if the buffer is already overlaying on the gel, then sometimes there is a chance that while you are putting the sample in the well, the sample may get diffused in the buffer. Okay. Of course, that doesn't happen. That is not a very serious problem. But some people feel that if they put the sample in the well, then there is a chance that the sample might get sprayed in the buffer, and therefore they don't overlay the gel with the buffer completely. Okay. Then what is agarose used for? Agarose gel can be used for either DNA electrophoresis, or it can also be used for protein electrophoresis, right? Then coming to the
Yes,
instrumentation,
sir.
we have, yes, any question? We have a power pack. What is the function of the power pack? It will provide the electric current. Okay, it provides a direct electric current between the electrodes. And then we have something called as either a single mode or a dual mode electrophoresis chamber. What is the meaning of a single mode, and what is the meaning of dual mode electrophoresis unit? Anybody?
Dual mean double mode.
Yes, double mode. The simple meaning here is that in one single apparatus, you can run two gels at the same time. Okay. Some
Yes.
people want to carry out multiple experiments, isn't it? So they can run two gels on the same apparatus without wasting time or without spending more on a second electrophoresis unit. Okay. Now, when the potential difference is applied or when the voltage is applied across the electrodes, then the molecules will start moving. These molecules have different charges. And then as they move, they have different rate of movement. And because of the different rate of movement, they will get separated from each other, right? Then coming to this important part, the buffer. Yes, I have written some names here. Normally for electrophoresis, we use tris glycine buffer, or we use tris acetate buffer, we use tris phosphate buffer, and we also use tris borate buffer. These are very commonly used buffers for electrophoresis. Usually the concentration is 0.05 mole. Okay, anybody wants to say something? Then, as I mentioned earlier, the pH of the buffers is adjusted in such a way that we have a particular property which is given to the sample components. Either the sample components are made more negatively charged or they can be made positively charged, because we want to separate a particular component of interest, isn't it? So if we have some idea about our own component of interest, then we can adjust the pH of the buffer so that that component will be properly resolved, or it will be separated from the other components.
Sir, I want to ask something.
Yes.
Uh, Depending upon the concentration of sample, can't we change the concentration of buffer as well?
Depending upon the sample.
Concentration of sample, can't we change the concentration of buffer as well?
It is not usually required. Most of the time, the concentration of the buffers are fixed. Actually, they are standardized concentrations.
Sir, I think they are fixed by the sir, I think, for example, high media has other kind of concentration, and other companies have other concentrations of their buffers.
Normally, the concentration do not change much, because the concentration is adjusted in such a way that the electrophoresis run will take place properly for 3 to 4 hours of your electrophoresis. Okay. The only concern here is that if the ionic concentration is very less, then what will happen? The electric current will not flow properly, isn't it? There will be more resistance rather than the flow of current, isn't it?
Sir, but for the flow of charges and current, there should be more than 0.10 molar concentration of the buffer. I had read in chemistry, means the
0.10.
I'm getting,
okay.
Yes, and I'm just literally getting confused in this statement.
No, I have written here 0.05 and you are saying 0.1.
Yes,
isn't it?
molar concentration
Yeah,
for
so
the
that is okay.
flow of charges.
So it's almost the same actually. It's not making a lot of difference, isn't it? Some people may use 0.1 molar concentration. Some people may use 0.5. The only idea here is that to keep the electrophoresis process going on, isn't it? Electrophoresis should not stop. The ion should not get dissipated. Now, if we are going to see if the electrophoresis run is going to take place for a longer time, say 6 hours or 10 hours or 15 hours, then you have to increase the concentration of the buffer. Is it okay?
Yes, sir.
So normally the concentrations are standardized so that the electrophoresis will run for at least 3 to 5 hours without any problem, right? Another thing I would like to just add to this question is that if you increase the concentration beyond the standardized one, then the chances are there that there will be a shielding effect. Or did I say that the competing ions in the buffer will also alter the mobility of your sample components?
Yes, sir. Yes,
Do you
sir. You
remember
told
that?
earlier.
Yes.
Okay.
Yes,
so
sir.
if the ionic concentration is too high, then that will also spoil your electrophoresis. Okay, it will hinder the movement of your molecules. If the ionic concentration is too low, then electrophoresis will not continue for a longer time. Okay, so between these two, between very high and very low concentration, you have to set up some standard concentration. Is it okay? Okay. Then there are two different modes. Of course, the time again is short. I have only about 8 minutes now. Okay. So what shall I do? I'll complete this part and we'll end the meeting today. Okay. I'll only complete this part. Okay. There are two different modes which are used: a constant current mode and constant voltage mode. So the power pack which we use for electrophoresis, there are two options given to us. Either we can run the electrophoresis at a constant current. So what will happen when we put this at a constant current? Suppose we are setting it at say 50 ampere. Okay, just as an example, I'm saying 50 milliampere current. Then even if your sample ions are getting dissipated as your electrophoresis run goes on, the sample ions are getting dissipated. Why they are getting dissipated? Because the negatively charged ions in your buffer will go to the positive electrode. They are not going to come back again, isn't it? So your buffer ions are getting dissipated with the run. Now suppose you put a constant current, then what will happen? As your sample ions are getting, the concentration is getting lesser and lesser, it means that your current will become lesser and lesser, isn't it? Now in order to maintain the same level of current, what the instrument will do is automatically it will increase the voltage. Okay. But now what will happen is, because the voltage will increase, okay, it means that the resistance in the medium is increasing. Resistance in the buffer is increasing. Your current is becoming less, isn't it? Because the ions are getting dissipated. In order to maintain the same level of current, the voltage will increase. And when the voltage increases, it will result in what is called as the heating effect. Do you understand what I'm saying? So
Yes, sir.
because the
Yes.
buffer will get heated up, it will also heat up the gel. And if the gel will heat up, then what will happen? It will result in distortion of your bands. Okay, there will be distortion of the band. This is also called as smiling bands. Can you see this word here? Smiling bands. Smiling bands, which means what? Instead of getting a straight band like this, you will get a curved band like this.
Curved band.
Okay, so that is called as a smiling band. This is because of heating. And if it is a smiling band, then sometimes you cannot carry out the analytical part properly, because you cannot exactly know what is the position of your band in the gel. Is it right? There is another mode which is called as the constant voltage mode. In this mode, what happens? As the ions are getting used up, the voltage will remain constant. Okay, and when voltage will remain constant, it means that the heating effect will not be there, because current will go on decreasing over time. Are you getting what I'm saying? As the buffer ions get dissipated, the current will become lesser and lesser, but voltage will be maintained to a certain level. And when voltage is maintained, the heating effect will not be there. Okay. The drawback of this method is that the migration will become slower later. Initially, the bands will move fast, and then the bands will move very, very slow, because the current is becoming lesser and lesser. Okay, but the advantage here is that there is no heating, and therefore the bands will be straight. There will be no smiling bands in your gel. I think we'll stop here today. Okay, whatever little time we have, if you have any questions, then I will answer your questions. Yes, you can put on your mics. No questions? Amol,
No, sir.
Aishwarya, Prashant, Yogita?
No, sir.
No
Questions,
questions. Dhaneshwar, Anuradha, Sudarshan?
No, sir.
हा ऐकायला नाही आलं मला. जोगदंड?
No, sir.
श्रद्धा, प्रगती, नवघरे, पूजा? मीनल? मीनलला काही आहे का प्रश्न? सोनाली? सोनाली ऐकतीये का? Sonali, put on your mic. Vaishnavi, any question? ठीक है, सगळ्यांना समजलंय का?
Yes, sir.
Yes, sir.
ओके. मग समराइज करायचं का आपण? Who will summarize? कोणाच्या माईक मधनं आवाज येतोय जरा बघा. कोणी सांगेल?
समराइज मध्ये काय करायचं सर?
समराइज म्हणजे तुम्ही मला सांगा आज आपण काय काय शिकलो ते. हा, मी तुम्हाला एक एक स्लाइड पाहिजे तर दाखवतो. लेट अस स्टार्ट विथ दिस स्लाइड. इलेक्ट्रोफोरेसिस सेटअप बघितला आपण आधी. We have seen about starch gel electrophoresis. We have seen the advantages of using starch. We have also seen the disadvantages of using starch. बरोबर? Advantage काय आहे? Non toxic, biodegradable. Okay, drawback काय आहे त्याचा? Non uniformity. Quality is not
easily
uniform.
get bent. Yes.
Easily get
Bent.
bent. Okay. Not useful for work.
Only usable at horizontal gel electrophoresis.
Right. एकदम बरोबर. हा. काय? अजून काय बघितलं आपण?
Vertical electrophoresis unit.
व्हर्टिकल बघितला आपण, राईट. अजून
Acrylamide is quite rigid in structure. That's why it is only used in a vertical electrophoresis
बरोबर
unit.
बरोबर. पण हे लक्षात घ्यायचं, आपण नंतरच्या लेक्चरमध्ये बघणार आहे की अक्रिलामाइड की अगारोज, डीएनए साठी की प्रोटीन साठी असं काही नाही आहे. दोन्ही पण जेल्स आपण डीएनए साठी पण वापरू शकतो आणि प्रोटीन साठी पण वापरू शकतो. पण ते चॉईस कसा करायचा ते मी नंतर सांगणार तुम्हाला. ओके, प्रोटीन साठी अक्रिलामाइड वापरायचं का डीएनए साठी वापरायचं हे आपण नंतर बघूया, राईट. किंवा केव्हा कोणता वापरायचं ते आपण बघूया नंतर. त्याच्यानंतर आपण काय बघितलं, वी हॅव सीन अबाउट द कोम्स. 3 प्रकारचे कोंब आपण बघितले. त्याच्यातले इम्पॉर्टंट म्हणजे हे नॉर्मल कोंब आणि प्रिपेरेटिव्ह कोंब हे आपण बघितले.
Preparative comb.
ओके, प्रिपेरेटिव्ह कोंब मध्ये 2 दात आहेत, 2 टीथ. वन इज फॉर लार्ज अमाउंट ऑफ सॅम्पल अँड अनदर इज फॉर प्रॉबॅबली द लॅडर पण टाकता येतं, म्हणजे मार्कर ज्याला आपण म्हणतो है ना, मॉलिक्युलर वेट मार्कर त्याच्यात टाकता येतील, किंवा स्मॉल अमाउंट ऑफ सॅम्पल कॅन ऑल्सो बी पुट हिअर. आणि नंतर आपण काय करणार आहे, जेलमध्ये जेव्हा बँड येतील तेव्हा बँड कसे दिसतील आपल्याला, कसे दिसतील.
Extraction साठी.
एकच सेकंद, मी इथे व्हाईट बोर्ड येतो का मला बघतोय मी. एक बोर्ड असतो ना ह्याच्यामध्ये, इथे काही मला दिसत नाहीये. मगा मला सापडला होता. हा इथे इथे
पेन्सिलचा आयकॉन आहे.
हा हे बघ, हे इथे दिसलं मला. हे दिसतंय का तुम्हाला?
हो सर.
हा, तर आपल्याला कसं दिसतं बघा, एक असा बँड येणार आहे आणि एक आपल्याला असा मोठा बँड येणार आहे, बरोबर आहे. बरोबर.